Good morning, and thank you all for coming. Give a short presentation on from Berkeley to Britain and back to California. So I worked in Martin's lab in the mid-90s, from 91 up to about 97. So these are some of the people here that came to know and love in the lab. And at that time, well, I tried to think of something kind of an interesting story. There was a shoe fight once, but Martin, thankfully you weren't there for that one. There was the time Martin brought his son and his mouse into the cell culture room while I was doing my cells to euthanize a mouse or a pet rat, and that was kind of a difficult situation for me. But one of my most enduring memories of that time was Martin would come in with this magazine, Current Contents, and the younger people in the crowd won't realize, but you couldn't read the literature back then without going to the library. But we didn't know what to read. There was just a billion books, but Martin would always come in with this and carefully circling all the interesting articles, which I felt very fortunate to run off to the library to know what to put in the copy machine. That's what, after a while I felt, am I a glorified secretary here? But I learned so much. I read the articles, I gave some information back to Martin, figured out what to throw away and what to keep. And thank you for that. Now I do the same thing to my students. They're doing journal clubs for me. I don't have a lot of pictures from back at that time. This is all I could find. Martin working very hard here at a housewarming party, also taking care of the kids. Eventually I graduated, and now I'm very happy to say that one of my postdocs is now an assistant professor working with me. That's Adam DeSmith at the right of me here. He's also from England, the Imperial College graduate, and his student is standing to the right of him. So now we have 4 generations here. And I'd like to hear from some other professors. How far does this go? Do you get to 5? Do you get to 6? I'd really like to know if you've gotten that far. Another thing about lab productivity is what kind of relationships people make. And I'm very fortunate to have made the most important relationship of my life in Martin's lab. And that's with Iris Wong, who's now my wife. And there's a couple of our productivity standing with us there in Banff, Canada. They're teenagers now, so not quite so cute. This is my first paper, and I think your first paper is kind of like your first girlfriend. It's you could do better someday, but it's seeing your name first. It's extremely gratifying, and I was really happy to know that our presentation, or at least our morning session, was actually named after my first paper, which is in the journal Free Radical Research. After graduating from Martin's lab, I decided to concentrate on a disease rather than toxicology in general. And I went to Britain to work with Mel Greaves here. We're standing here emulating the Half Dome behind us. And Ching Lan, I'm sorry, you probably don't know which is which, but I'm on the right here. I worked with Mel on childhood leukemia, a large epidemiology study in the UK that collected samples from 92 to 97. And kind of a synthesis of some of the work that we did there, and also back here in California, is to define when the genetic changes happened leading to childhood leukemia, as sort of a way to define the natural history of the disease and know how to discover the causes of those events. So on the left-hand side of this slide are just names of some subtypes of childhood leukemia, and on the right-hand side is the genetic events that happen in this disease and when they happen, allowing us to focus on those times of the child's life to discover the causes of the cancer. As I mentioned, this work did continue when I came back to California, and Cleona, the same Cleona who's organizing the meeting, is one of the people involved in doing this backtracking. just a summary of that, this backtracking and how it allows us to look at certain times in a child's life and potential risk factors at those times to study. Now, when I started back here in California at UCSF, one thing was gathering and building resources for study. One of them was already here. Even while I was a student in Martin's lab, he and Pat Buffler had started the California Childhood Leukemia Study, which I happily became one of the primary investigators using samples from that study. And since that time, we've also constructed a couple of other resources. One is the California Study of Early Onset Cancer. That's with collaborators here, Catherine Metier at UC Berkeley, and also Xiaomei Ma at Yale University. And also, I won't talk about it today, but we have another registry-based study using the Neonatal Blood Spot Biobank of California to look at family-based cancer in siblings and twins. So I'll just highlight a couple of things over the past few years that have kind of driven my research directions. One is this observation we had on a postdoc in the lab, Jeffrey Cheng, wanted to study cytokines in neonatal blood spots, which I thought was crazy at the time. How would you look at proteins, do immunoassays on blood spots? But we found in a small sample of subjects from the California Childhood Leukemia Study, this sort of profound deficit in a cytokine, interleukin-10, in children. This is at the time of birth when the children are very healthy. They get leukemia years later, but they have this profound deficit in this cytokine, which really was some kind of a clue that something's going on that we don't understand, because in epidemiology of childhood leukemia, we always talk about infections during the child development after they're born as being the most important for the etiology of the disease. So in the last 10 years, this has really been the biggest puzzle to try to uncover. We've looked at one feature, which is how the child interacts with the mom. In the fetus, the fetus needs to repress the strong immune reactions from the mother because the fetus is expressing antigens from the father. And the way that this is done is interactions between HLA on the child placental cells and KIR receptors on natural killer cells in the mom. And we found that these do affect cytokine levels at birth, especially in Latino and non-Latino Asian children who do have the higher risks of childhood ALL. More recently, though, we found another clue, which I think will end up being maybe one of the most important observations of my career. And what we did is we tried to look for a virus that's specific for acute lymphocytic leukemia, which is known to be sort of the infection-related type of leukemia. And we compared it to acute myeloid leukemia rather than just healthy children, which is the way people have done it in the past. And we found a single virus which was present in the ALLs compared to AMLs, and that's cytomegalovirus. Interestingly, this virus is also commonly present in the child in the neonatal blood spot at the time of birth, indicating that it's probably early infection, which is key, because CMV is not known to be a leukemia causing virus. We saw the same thing in the Swedish registries, looking at their linked databases. And more recently, we found that this seems to be specific for the high hyperdiploid subtype of childhood leukemia, which is the most common subtype. About 30% of the ALLs have this phenotype of having extra chromosomes. So Rachel Gallant in our lab, she's done a further study on looking at CMV in childhood ALL to try and understand how to link this up with the other observation we see with childhood ALL, which is that more fulminant or strong infections seem to be induced with risk. And what she finds is that children who have CMV in their leukemia cells tend to respond more strongly to infections. And this, again, is using California Childhood Leukemia Study data. And this study, I'm very gratified that the key characteristics includes at least two categories, immunosuppression and inflammation, because I believe those are exactly what we're studying here in the development of the child. right now we're studying it in relationship to viruses and infections, but I think we do need to do more with toxicological chemicals as well. But speaking of chemicals, we do have one which is associated with a feature of childhood ALL, and it's maternal smoking. So this is a study where we looked just in the cases, childhood leukemia cases, and we looked at the presence of gene deletions. So the tumor can have between 0 and 6 deletions at key hematopoietic transcription factors. And in this case-only analysis, you can see that more smoking, especially when during pregnancy and breastfeeding, leads to more deletions in the leukemia cells. And more recently, we've confirmed this using a DNA methylation biomarker of smoking, or a polyepigenetic smoking score, leading to this idea that tobacco exposure around the time of birth and after birth leads to off-target recombinase activating gene expression and leading to gene deletions that then lead to the overt leukemia. And interestingly, these childhood leukemias with deletions are not the hyperdiploid leukemias. So what this does is it splits leukemia into two etiologic pathways, one which seems to be virally related, and the other which seems to be chemically related, or in this case, related to parental smoking. So my position is in the Center for Genetic Epidemiology, so they expect me to do genetics, and we've done quite a bit on pediatric cancers, including ALLs, looking at a number of genetic risk factors here. Gliomas have been a tougher nut to crack. We only have a single GWAS hit for gliomas, hasn't been published yet. But on the array that we used to do this GWAS study for gliomas, we also had a number of mitochondrial variants to look at. The mitochondrial genome is a small genome, about 16,000 base pairs inherited through the mom. And we found this single variant at position 1555 has a very strong relationship with pediatric glioblastoma, which is a very rare disease. But we think this is leading us to some clue about this, the etiology of glioblastoma. The same variant is associated with shorter height in the UK biobank samples, and it's also responsible for hearing loss in some children. But this has brought me back to toxicology, because now with this observation about a metabolic genetic phenotype related to pediatric glioma, this is a pilot study here where we found 5 of these human serum albumin adducts to be elevated in children at birth who got pediatric glioma in their future, glioblastoma. And this is work with William Funk in Northwestern University, who's a former, can't remember if he's a postdoc or a student of Steve's, PhD student. So I feel like we're still back in the family here, which is great. Finally, please look up our lab. These are some of the people doing this work at USC. And thank you, and thank you, Martin, for setting me off on the road and still working on the same sample sets. It's wonderful.
Hi. It was a wonderful experience to join this exciting work on childhood leukemia as a postdoc in the Smith Lab in the early 2000s. As Joe mentioned, my research with Martin, Joe, Pat Butler, and others used backtracking to confirm that 1221 translocation associated with childhood ALL occurs prenatally. And in a proof of principle study in a small number of patients also showed that the 1517 and inversion 16 translocations, inversions, may occur prenatally. And then I co-authored papers with Martin and others showing how these findings informed our understanding of childhood leukemia and the contributions of chemicals, infectious agents, and genetic susceptibility. In my 24 years with Martin and the Superfund Research Program, I've worked with many wonderful students, postdocs, and collaborators on a variety of projects, including biomarkers of benzene exposure, mechanisms of benzene-induced leukemia and implications for risk assessment, approaches to cumulative risk assessment and exposome, and the key characteristics. It wasn't always easy. We had 2 lab moves that were a bit of a challenge, but due to the Herculean efforts of Wei Hong and Sylvie at the time, we survived and we thrived. In the ups and downs, I have learned what Martin's key characteristics are. He has, they're good. He has a flair for embracing and developing big concepts like the exposome, conceived with Steve Rappaport and others, and the key characteristics conceived with Vince and others. He has an impressive ability to connect incredibly smart and creative people and weave ideas across disciplines and spheres in ways that enable these concepts to gain traction in meaningful real-world applications that enhance environmental health. He inspires students to see the bigger picture. Martin's approach to collaborative research exemplifies the scientific process that I wish the public could appreciate: deep listening, respectful discussion, and consensus forming, and reiteration and recalibration with the humility that there is always more to learn. I am excited to continue in the next chapter of the Smith Lab, the Superfund program, and the key characteristics. Thank you.